It's the most haunting silence in human history. We point our most powerful telescopes at the sky. We're scanning for a signal, a beacon, a hum of machinery, just a single hello. And what do we get?
Static. Just an endless cold hiss of background radiation.
Welcome to the Ryland Report. I'm James Ryland.
And I'm Claire Ryland.
Today, we are diving deep into the ultimate existential question. It's the question that, I have to admit, keeps me up at night, staring at the ceiling. Are we truly alone in the universe?
It's a question that divides us right down the middle, doesn't it? I tend to look at the data, or, well, the lack of it, and I have to conclude that we're probably a magnificent accident. A fluke.
See, and I look at the sheer scale of the cosmos and think, there is absolutely no way. It's just too big, too old, and too filled with potential for us to be the only ones here.
Well, today we are going to test those convictions. We've pulled together a stack of research. We're talking papers from Oxford, theories from NASA scientists, and arguments from evolutionary biologists to really tackle the Fermi Paradox.
So let's set the scene. The year is 1950, Los Alamos National Laboratory. This is where the atomic bomb was born, so you have, the highest concentration of geniuses on the planet.
Right. And the physicist Enrico Fermi is walking to lunch with three colleagues, Emil Konopinski, Edward Teller, and Herbert York. And they're just casually discussing faster-than-light travel and a recent rash of UFO sightings in the news.
Standard cafeteria talk for physicists, And in the middle of all this, Fermi just stops and drops the question that stopped everyone in their tracks. But where is everybody?
And it sounds like such a throwaway line, but Fermi was doing this rapid mental calculation. He realized the galaxy is billions of years old. So even at really slow speeds, a civilization could colonize the entire Milky Way in just a few million years. So they should be here. They should be everywhere.
But they aren't.
Yeah.
And that right there, that is the core contradiction. The math says the universe should be this crowded party, but observation tells us it's a completely empty room.
Let's actually look at that math for a second, because the scale is what makes the silence so deafening.
Oh, it's just staggering. In our Milky Way alone, estimates sit between 200 and 400 billion stars.
And that's just our local neighborhood.
Exactly. You zoom out to the observable universe, and you're looking at roughly 70 sextillion stars. That is a 7 followed by 22 zeros.
It's a number the human brain isn't actually equipped to handle.
So even if life is like winning the lottery, if you buy 70 sextillion tickets, you're going to win a few times. Even if intelligent life is, 1 in a billion, we should be swimming in signals.
And this is where Frank Drake tried to bring some order to the chaos back in 1961 with the Drake equation. It's a formula to estimate the number of active, communicative civilizations in our galaxy.
Right. It multiplies all these factors like the rate of star formation, the fraction of stars with planets, the number of planets that could support life, and so on.
It's a beautiful piece of logic. But there's this one massive glaring problem with it. We know the astronomical numbers. We've got a good handle on stars and planets. But the biological and sociological numbers, the fraction of life that becomes intelligent, the lifespan of a civilization, we're just guessing.
We're just plugging in hunches and calling it data.
Precisely. And this is where one of our key sources today just changes the game completely. It's a 2018 analysis by Anders Sandberg, Eric Drexler, and Toby Ord at Oxford University.
I love this paper because it stops pretending we know the answers.
Exactly. They argued that using single estimates for the Drake equation is totally misleading. Instead, they used probability distributions ranges of uncertainty. They admitted that for some of these variables, our uncertainty spans orders of magnitude.
So instead of saying 1% of planets have life, they said, look, it could be anywhere from nearly 0 to nearly 100%.
And when you run the math with those honest uncertainties, the picture changes dramatically. They found a substantial probability, around 53%, that we are alone in the Milky Way.
Wow, that is a buzzkill. It basically takes us from where are they to, a coin flip.
It sort of dissolves the paradox. The silence isn't strange if we're the only ones here to begin with.
53% isn't 100%. That still leaves a massive chunk of probability that they are out there. So if I'm betting on the believer side, I need to know, if they exist, why can't we hear them?
And this is where we have to look at the barriers, the hurdles that life has to jump over. We call these the great filters.
The idea that there's some wall in evolution that is incredibly hard to get past.
And the most terrifying question in this entire field is the filter behind us or is it ahead of us?
If it's behind us, that's great news. It means the hard part was abiogenesis. Life sparking from dead matter. Or maybe it was the jump from single cells to complex cells. If we cleared that, we're the lottery winners.
But if the filter is ahead of us, that implies that intelligent civilizations rise all the time, but something wipes them out before they can colonize the stars.
Nuclear war, engineered pandemics, unchecked AI, resource collapse.
It suggests that technological civilizations are inherently unstable, that they self-destruct.
Let's look at the physical constraints for a minute, because there is a fascinating theory about why a civilization might be alive and well, but just unable to call us. We have to talk about the oxygen bottleneck.
This is such a brilliant insight from Amedeo Balbi and Adam Frank. We tend to assume that if you're smart, you build spaceships. But there is a step in between. Fire.
You need fire to smelt metal.
Exactly. You need an atmosphere with at least 18% oxygen to sustain open combustion. Now imagine a planet with a thick atmosphere, but low oxygen, or an ocean world.
You could have incredible intelligence there. Creatures as smart as us with complex languages, philosophy, maybe even mathematics.
But if they can't light a fire, they can't forge bronze or iron or steel, they can't build a steam engine, and they certainly can't build a radio transmitter or a rocket.
So they are trapped in the Stone Age forever, not because they're stupid, but because their planet's chemistry won't let them level up.
They could be screaming into the void, but without the right technology, we'll just never hear them.
That connects to the rare earth hypothesis too, doesn't it? The whole idea that Earth isn't just some generic rock, but a freakishly perfect setup.
Oh, absolutely. Peter Ward and Donald Brownlee make a compelling case for this. It's not just about being in the Goldilocks zone. It's about having a guardian planet like Jupiter to suck up asteroids. It's about having a massive moon to stabilize our axial tilt so we get regular seasons.
And plate tectonics. We don't think about earthquakes as a good thing, but they recycle carbon and keep the planet's temperature stable over billions of years.
Without that very specific geological cocktail, you might get slime, but you probably don't get a civilization that lasts long enough to build a SETI program.
Okay, so those are the reasons we might be alone or, effectively silenced by nature.
Huh?
But let's pivot. Let's assume they made it. They have the tech, they have the rockets, they have the radio. Why is the sky so quiet?
This is where we get into the really tricky part, the psychology of aliens.
And one of the most famous theories is the zoo hypothesis. It's basically the prime directive argument from Star Trek.
Proposed by John Ball in the 70s. The idea is that advanced civilizations are aware of us, but they have a strict policy of non-interference. We're a nature preserve.
Or a quarantine zone. The Russian visionary Konstantin Tsiolkovsky suggested this almost a century ago. Maybe we're too violent, too immature. They're watching us like bacteria in a petri dish, just waiting to see if we evolve or die off.
It's a comforting thought, in a way. It implies they're benevolent, or at least scientific. But there is a much, much darker interpretation of why everyone is being so quiet.
The dark forest.
This comes from the sci-fi author Lou Sixon, and it is just terrifyingly logical. Imagine the universe isn't a bustling city, but a dark forest at night.
And every civilization is a hunter armed with a gun creeping through the trees.
You don't know if the other hunters are friendly or hostile, but you do know that if they find you and they view you as a potential threat to their own survival, the safest move is to eliminate you immediately.
So the silence isn't because the forest is empty, it's because the forest is full of predators, and everyone is smart enough to keep their mouths shut.
Except us. We're the ones lighting a big bonfire and screaming, "Hey, we are here!" into the dark.
That really reframes our attempts at communication, doesn't it? Instead of sending out greeting cards, we might be sending our coordinates to a firing squad.
There's a similar concept, the berserker hypothesis, the idea that there are these self-replicating machines, von Neumann probes, that are programmed to just destroy any emerging organic civilization they find.
So if that's true, then the silence really is a survival strategy.
But let's step back from the predator scenarios for a second. There's a geographical explanation that could be much more common, even in our own solar system. We call them ice worlds.
Alan Stern's theory. This one makes so much sense to me. We look for life on the surface of planets because, well, that's where we live. But look at Europa or Enceladus right here next door.
They have vast liquid oceans, but they're buried under kilometers of solid ice. Stern argues this might be the default mode for life in the universe.
So imagine a civilization evolving down in that ocean. They're warm, they're protected from radiation, they have energy sources.
Yeah.
But they have a literal ceiling over their heads.
They would never see the stars. They wouldn't even know the rest of the universe exists. To them, the universe is just their ocean and the ice sheet above.
And trying to drill through 10 miles of ice just to see what's on the other side would be, that's like us trying to go to the center of the Earth. It's a massive engineering project with no obvious reward.
So they just stay down there, blissfully ignorant of the cosmos and completely invisible to us.
Now, there's another angle we haven't touched on yet. What if they aren't hiding and they aren't trapped? What if they just moved on?
The inward expansion theory. This is a fascinating sociological argument from thinkers like Avi Loeb and Nick Bostrom. We always assume that advanced means building bigger ships and conquering more land.
Because that's what humans have done for 10,000 years. Expansion is our default setting.
But a super advanced civilization might realize that physical space travel is incredibly inefficient. It's slow, it's expensive, and space is mostly just dead, empty void.
So instead of going out to the stars, they go into the servers.
Exactly. Once you master computing and virtual reality, why spend millennia traveling to a barren rock when you can upload your consciousness into a perfect, simulated paradise?
The ultimate metaverse.
They could be running billions of simulated universes on a computer the size of planet, experiencing things we can't even begin to imagine. They haven't expanded outward, they've expanded inward.
And to us, looking from the outside, their planet would just look like a warm rock. They wouldn't be broadcasting radio waves, they'd be managing internal data streams.
It also boils down to pure economics. There's a concept called a universal limit to technological development. It suggests that interstellar travel just never becomes cheap.
It's always an enormous resource sink.
Right, so you might send information, maybe you beam your encyclopedia to other stars, but you'd never send biological bodies. It's just not worth the cost.
And this brings us to the algae versus alumni problem. I love this phrase.
It's the distinction between detecting simple life and intelligent life. We can find algae by analyzing the light passing through a planet's atmosphere. If we see oxygen and methane, we know something is breathing down there.
But finding alumni, the college graduates, requires them to be doing something we can actually see. And we assume they use radio waves because that's what we use.
But we've only been using radio for about a century. And we are already moving away from high-power broadcasting toward things like fiber optics and directed laser communications.
Earth is actually getting quieter. A radio telescope 100 light years away might have heard our TV broadcast from the 1980s, but they might not hear our internet traffic today.
We might be listening for smoke signals while everyone else is using fiber optics and neutrinos. We could be surrounded by chatter that we simply don't have the ears to hear.
I want to circle back to the timing aspect because this is the one that actually gives me the most hope. The firstborn hypothesis.
This is the idea that we aren't alone, we're just early to the party.
It feels arrogant to think we're first, but the science might actually back it up.
It does. The universe is about 14 billion years old, but for the first few billion years, it was a chaotic mess. It was too hot, and there weren't enough heavy elements, carbon, oxygen, iron, to build stable planets or biological cells.
Right, those elements had to be cooked inside the first generations of stars and then blasted out in supernovas.
Avi Loeb has suggested that the universe has only recently become habitable for complex life.
So if you look at the timeline of the cosmos, we might be the first batch of cookies out of the oven.
Which means there are no ancient galactic empires because they haven't been born yet. We are the ancients.
We're the ones who are going to leave the ruins that future civilizations wonder about.
But there is a counter-argument to the timing theory, specifically regarding grabby aliens.
This is from Robin Hansen's model, right?
Right. He argues that if a civilization can expand, it does so exponentially. It becomes grabby. It colonizes star after star, changing the universe as it goes.
And since we look out and see a pristine, untouched universe, no Dyson spheres blocking stars, no galactic highways, we have to conclude that these grabby civilizations must be incredibly rare.
Or, again, we are just the first ones to wake up.
It connects back to sustainability, too. Adam Frank's work on exo-civilizations suggests that maybe civilizations don't become grabby because they burn out first.
And honestly, both possibilities are equally frightening. As Arthur C. Clarke famously said, two possibilities exist. Either we are alone in the universe or we are not. Both are equally terrifying.
If we're not alone, then we're the new kids in a potentially dangerous neighborhood. We're the noisy campers in the dark forest.
But if we are alone, if we are the firstborn, then the stakes are just incredibly high.
It means we aren't just one species on one planet. We are the torchbearers for consciousness in the entire galaxy.
And if we destroy ourselves, if we let the great filter of climate change or war wipe us out, We aren't just ending human history. We might be extinguishing the only light in the Milky Way.
That puts a lot of responsibility on us, doesn't it?
It does. It means we have to get this right.
We want to leave you with one final thought to mull over. We call it the Great Silence. When you walk out tonight and look up at those stars, just listen to that silence.
Is it the peace of an empty, open frontier waiting for us to explore? Or is it the held breath of a billion worlds hiding in the dark?
The search continues. And until we find an answer, we'll keep looking up.
Thanks for listening.
This has been the Ryland Report. Goodbye.